Hi everyone, this is the IB Probability and Set Theory package. This is the section on conditional probability, and this is example 14. Putting it all together here. Okay, so we got three parts to this question here, three different things. It's all basically one big question here. Bag A contains 2 red marbles and 3 green marbles. Okay, 2 balls are chosen at random from the bag without replacement. Let X denote the number of red balls chosen. The following table shows the probability distribution for X. Okay, so we're going to calculate. So here's our probability distribution, and the first question here says calculate the expected value over the mean number of red balls chosen. Okay, so again, bag A contains 2 red and 3 green. 2 balls are chosen at random from the bag without replacement. So we're not putting them back in here. And so if X tells you the number of red balls shown here, so the expected value for X here is going to be the outcome times the probability plus the outcome times the probability plus the outcome times the probability. Just think back what we did a little while ago with expected value. And so what we're going to get here is this is going to be 3/5. The first term just disappears. Plus this is going to end up being 1/5. And so the answer here will be 4/5. Okay, that's the expected number of red balls chosen. Which I know looks a little bit weird, but this is on average, okay, right? This is the expected value here would be the average number here. Okay, next. Bag B contains 4 red balls and 2 green balls. 2 balls are chosen at random from bag B. Draw a tree diagram to represent the above information, including the probability of each event. Okay, so here we go. And so what are we looking for? 2 balls are chosen at random from bag B. So here we are at bag B here. So sorry, you can't see that here. It could be a red ball or it could be a green ball. So the probability of getting a red ball as the first ball here is going to be, and again, I believe that we're doing this without replacement here. So this is going to be, red will be 4 out of 6, and green here would be 2 out of 6. Okay, so we might write this as 2/3 and 1/3. Then we've got red, green, red, green. The probability here, so let's say that we've pulled out a red ball, so there's, what do we have here, 6, we've only got 5. There are going to be 3/5 of those will be red. In this case here, though, it will be just, whoops, I wrote a Z there. That's not what I meant. 2/5 are green. Now in this case right here, let's say you grabbed a green as the first one. Well, we've still got 4/5 are red here, but in this case only 1/5 is going to be green. So we're going to do here's our tree diagram, represent the above information including the probability of each event here. So what we've got here is RR, red, the probability of getting that is going to be 2/5. The product of those two, 2/3 and 3/5. The probability of getting red-green, okay, is going to be 4/15. Okay, the probability of getting green-red is going to be 4/15. And the probability of getting green-green, okay, is going to be 1/15. And if we add those all up, and we should just think about it, this is going to be 6, and 4 is 10, and 4 and 5, that's going to be, altogether that's going to be 1 here. And so there's our tree diagram. Now, part B here. Find the probability distribution of Y, where Y is the number of red balls chosen from bag B. Okay, so the probability that you don't choose a red ball is 1/15. Okay, that's up here, that's the green-green situation here. The probability that you get just 1 red ball is going to be the sum of those two, because it can happen either of those 2 ways here. So that's going to be 8/15, and the probability that you get 2 of them is going to be 2/5. So there's our probability distribution, okay? Every possibility with the probabilities associated with it. Now, a standard die with 6 faces is rolled. If a 1 or a 6 is rolled, 2 balls are chosen from bag A. Otherwise, 2 balls are chosen from bag B. So calculate the probability that 2 red balls are chosen. Okay, so here we go. To get 2 red balls, okay, that can happen. Basically what we're saying is the probability of getting red and red. Well, this can happen a couple of different ways here. This could either happen going for bag A, or it could happen going for bag B. So now let's take a quick look at this. What's the probability of choosing bag A? Well, bag A is going to happen if a 1 or a 6 is rolled. So that's going to be 2 out of 6. And if that happens, then the probability of getting 2 red from bag A is 1/10. I see that going way back up here. Getting 2 reds is 1/10. Okay. Or this could happen by looking at into the other bag here. And in the other case here, you're going to get that if you roll basically 4/6, okay, if you roll 2, 3, 4, or 5, and the probability of getting 2 red balls from bag B is going to be 2/5. Okay, and now all we got to do is just evaluate this. So what have we got here? We've got 1/3 times 1/10 plus 2/3 times 2/5. Oops. And our total answer here is going to be 3/10. Okay. Now, given that 2 red balls are obtained, find the probability that a 1 or a 6 was rolled on the die. Okay. So here we go. So we want to know the probability that we got a 1 or 6, given that, whoops, sorry, you can't see that, that we got 2 reds. So that is going to be the probability of a 1 or a 6 and 2 reds divided by the probability of 2 reds. Now the probability of a 1 or a 6 and 2 reds, we just saw before, that was 2/6 of 1/10. That's this part right here. So that is going to end up being 1/30. Okay, that's this part right here. And then the probability of getting 2 reds, well, we just figured that out. That was 3/10. Okay, and so now we're going to get 1 divided by 30 divided by 3 divided by 10. And our answer is, the probability is 1/9. And there we go. That's and you can see this is how this thing worked into a conditional probability sort of question.